This video is going to step you through the expectations for our data files requirement. If you scroll down to Standard 13 on Course Sites, and it covers some of Chapter 5 and some of Chapter 8, you have three options to complete this assignment. You're going to use data files in a previous program, and those programs are a little bit longer and more detailed, so you could use that with a partner, or you could choose one of the following programs from Chapter 5, or you can use data files in your semester project. I'm going to step you through just some of the programs from Chapter 5, and in class we will do a demo of how you actually set up a project to do this. So in Chapter 5, the first program that deals with data files is program number 16. I'm not actually going to run this code, we're just going to look at it and kind of study it. And a couple of things to note: in most of these examples, you'll see that they've accessed or they reference a particular data file. Like this one is called demo.txt. That data file would be looking something like this: mydata.txt or people.txt, or in this case demo file .txt. If I were to scroll up or down somewhere, I'd probably find that data file, or it's going to create it as it runs. And so this first program, when you're working with data files, remember that there's basically this process for working with data files where you need to open the file, you need to work with the file, and then you need to close the file. You also need to make sure that you have the correct #include directive. And so in this one, we're doing #include fstream. That stands for file stream. And we create an ofstream object, which is for output. You can name output file anything you want right here. Like some people just name it out. That's a variable name, so you can make that whatever you want. I would suggest using camel casing when you do that. You use that output file stream name here to open the file. So output file.open demo file.txt. And this particular one is creating a file for output. So it doesn't already exist anywhere, it will be created. If a file already existed with that name, it would be overwritten. And then these four names are written to the file in their one line per file line. Because of the /n, that's an end line, and so it hits return. So it'll be on four separate lines in the file. And then you have output.close. Our next program, number 17, very similar. We have a file stream object here. We had created an output file object. This one's going to open friends.txt. Only difference on this one is they're allowing somebody to input the data to variables, friend1, friend2, friend3, and then the output name1, name2, name3. Please notice right here, this is just like a count line right here. So it's just like you're doing count name3 to the console, but instead of going to the console, it's going to go to the file that is associated with output file, and that file is friends.txt. And at the very end, we close the file. Now this is not very efficient. Typically you want to make things more efficient in your program, and the series of programs we're going to look at here will refactor as we go along. This one's very similar. It's except for the fact that it's an input file. So the friends that we just wrote to the data file, in number 17, you wrote 3 friends' names, and number 18, you read them in. Again, it's #include fstream, but instead of output file, you create an ifstream object. It's called input file. If we look at the previous program, it was an ofstream object for output file. So of for output file, if for input file. And then we open the file, friends.txt. The way that this one is set up, you have to have that data file in a particular location on your project or in your project for it to work. They're not including a path name to that project, and so we will cover that in class. They input the names from the file, and notice right here where it's input file name, that's just like us using cin or sin to get data from the user. Example number 19 steps it up a little bit more and refactors using a loop, which would be more appropriate. This would be a more efficient way to process entering sales or entering names. You would not really want to create 12 different variable names. If you're reading input sales from 12 different companies, you want to process it in a loop and probably process it eventually to an array. But same type of a format. You have fstream for your pound include, ofstream for an output file. Create the output file here. If that file already exists, it will be overwritten when you create it this way. Create and work with the file, and then you close the file. Example number 20 is same thing, except they're using a for loop to read that data in. And so right here, this input file greater than sales is where the file is read in. So otherwise, the rest of the program is the same. Number 21, program number 21 opens a file for input, and this is where they really start to get to where the type of file opening and such that I would expect you to use. And that is usually this is done with a while loop. Now please notice this is an input file, so I'm reading in the data from the sales. Up to this point, we have to know how many particular pieces of data we had. Like we had to know if it was 5 sales data, 10 sales data, 20 sales data, or 500. But this particular loop allows us to read until the end of the file. That's what EOF stands for right here, is end of file. And so this is actually the best way to start to read in data from a file. Using a for loop is actually not practical, but it is there for demonstration purposes. So you input from the file, you input the data item to this variable sales, and if that works successfully, then this while loop will run. Again, notice you have open the file, work with the file, close the file. There are some other safeguards that we should put into place. So if we take a look at the next few programs, that will help us. And this one, for example, before we even read data in, it checks to see if the file is opened successfully. If I just use the word input file, my input file stream object, that should produce a true or a false value based upon whether the file was opened successfully. If the file was opened successfully, then we can go ahead and process the file with our while loop. So this one checks to see if it opened successfully. If it did, it runs this while loop. This particular while loop does not have braces at the beginning and the end because it's a one-line while loop. I would recommend that you put the braces in. And then it closes the file within that if statement. If it did not open successfully, please note that there's an error message. And so this would be the model that I would expect that you follow, and I will be looking at in your code. Number 23 is the last one from chapter 5. And it also allows, this program lets the user enter a file name. So as long as the file name is in a particular folder, the user can type in the file name as a C string object right here. And then that assigns it to input file. You successfully check to see if that file was opened. And then while it was opened, you go ahead and read the data in from the file. And then you close the file. Otherwise, you display this error message. That's it for the examples from chapter 5. I'm going to have a second video that does examples from chapter 8, and we'll show you in chapter 8 how to read data into an array, and or you could use it to read data into a vector, which some of you are using in your semester projects.